All right, so you see that the graph is not always increasing, and the graph is not always decreasing either. Okay, not increasing all the time, not decreasing all the time, but this locally. Let me just try to make the graph looks better. Okay, so when x run from negative infinity all the way to 0, x run from negative infinity to 0. So you see the first half of the graph from here to here, from here to here. The graph is going down, right? So you say what? On the interval from negative infinity to 0, the graph is decreasing. Okay? And then on the interval from 0 to infinity, the graph is increasing. Okay? Increasing means going up. It means what? When you plug in any value of x in this interval from 0 to infinity, the bigger the value of x you plug in, the bigger value of y you get. The other way around, on the first half, you plug in bigger x, you get smaller y. Okay, so let me just randomly draw a graph and I'll show you more intervals. Okay, so if I have a graph like this. Randomly. So this is going to be, say, -1. This is going to be 3. Okay, this is my x-axis, and this is a y-axis. So by looking at the graph, you see what? First of all, the graph is increasing, hit the top, and what? The change direction be decreasing, hit the bottom, and then go back increasing, right? So you can write this way, from negative infinity all the way to -1, the graph is increasing. This means increasing, okay? Then what? Well, next from 1 to 3. X from 1 to 3. From -1, I mean, to +3. Then the graph is decreasing. It's going down. The graph is going down. In other words, the function is decreasing. And then when x from 3 to infinity, then the graph is going back to increasing. So monotonicity, increasing or decreasing, is a local property of a function. Maybe increasing on some interval, maybe decreasing on the other interval, and then back to increasing. Maybe flat. So far, so good. Okay, that is the second property. Increasing, decreasing function. All right. Now, we're going to talk about the next property, maximum and minimum. I can use this graph again, but now let me just erase it out to draw another one. Property number 3, maximum and minimum. Okay, as I claimed previously, this is college algebra, so we learn properties via observations. It means what? By looking at the graph, we can see some properties, okay? And I keep emphasizing what? This way of doing is not a formal way to do math, because it's just beginner, so we do it that way. But I claim that we are preparing you guys to get to calculus. When you get to Cal 1, and you're going to see that those properties again. You're going to find maximum and minimum, and you don't just say, what? By looking at the graph, I find the answer. That will not be okay anymore. You have to do it algebraically. It means what? You have to show your calculation to find the maximum and mean. But that's for later, okay? For now, we're going to have some idea. We're going to learn some idea of maximum and minimum by looking at the graph. So, we have two types of max and mean. Whatever you learn for math, you can apply the same way for mean by similarity. But we have two types of max and two types of mean. The max or the mean, we have what? Absolute max or local max, and then absolute mean or local mean. Okay? Let's talk about absolute. First of all, absolute max or mean. Talk about absolute max or mean, you have to look at the entire function. Look at the entire domain. Okay? Say for example, if we have a graph like this, and this is a solid dot. This is a solid dot. Okay? So the domain is run from here to there. we're not going to go down forever, not going to go up forever. If this is our graph, then what? This will be your absolute mean. This will be your absolute max. So absolute means what? The biggest and smallest for the entire domain. Absolute mean means the lowest point for the entire graph, for the whole graph. Whole graph means the whole domain, okay? And similarly, absolute max means the highest point on the entire graph. Okay, so let me change the graph a little. What if this graph tends to go up forever, never stop? You see what? You will have no absolute max because you cannot find the highest point for the graph. The graph keep going up forever. Okay? No absolute max. But you do have an absolute mean right there. Okay? Because this is the lowest point for the graph. And similarly, what if this graph is like this? Just keep going down forever. Keep going up forever. And you do not have any absolute mean or absolute max because one point of the graph keep going down forever. You cannot find the lowest point. Another point of the graph keep going up forever. You will not have any absolute max. Okay? So some graph may have a absolute max, no absolute mean. Some other graph may have absolute mean, no absolute max. Some graph may have neither one of those. Okay? Some have multiple. Say for example, say I have the wave function, say the sine function. Keep going this forever, and it's the same height, right? So those are all absolute max because those are all the highest points of the graph, and those are absolute mean. Okay? So you may have more than one. Or say half a circle. So you have this. Okay, this is my half circle. You see what? This is my absolute max, the highest point for the graph. I do have two absolute means. Those are 2 points because my graph is what, half a circle. You see? So you may have one, may have multiple absolute max or mean. Okay. Anyway, absolute max or mean, you think of what? The highest or lowest point on the entire graph. Highest or lowest points on the entire graph. Is that an ink? Highest or lowest point on the entire graph. Okay? And one more time, this probably you may have it, you may not have it, depends on the function. Alright? Now, let me talk about the second type of max and mean. Number 2, we'll be talking about local max or mean. See? I did not show you how to find a max or mean algebraically yet because it's really beyond the scope of our course. Okay, but I keep saying it because I hope that many of you guys are going to move on, get to Calculus 1, and you're going to learn the real deal of it. You're going to find the exact maximum and minimum using algebra. Not by observation. I see it on the graph. Okay? Local max and local mean. So let me demonstrate using the graph again. Local. We talk about a local region. We don't talk about the entire domain anymore. Okay. So a local region in math means what? An open interval. Okay? So a point right here. If I can find an open interval, a local region means an open interval, and just within that interval. Alright, within that interval. I'm not looking at the entire graph anymore. If I can look at an open interval and I can find a higher points on it, this will be the local max. Similarly, if I want to find a local mean, I am not looking at the entire function. I only look at an interval, an open interval, okay? A small open interval. And I can find the lowest point. This is going to be the local mean. Okay? So sometime you may have local max, sometimes you may have local mean, sometimes you may have both, sometimes you may not have any of those. Say for example, you have a line going up forever, going down forever. You don't have absolute max, you don't have absolute mean, you don't have local max, you don't have local mean. Graph going up forever, this side, going down forever, this side. No extremum, no local or absolute maximum. Okay? Say if you have a problem, okay? Going up forever, no absolute max, no local max. Can I find a local mean? Yes, right here. This point is a local mean. Again, one more time, for local, you don't look at the interval, or the entire domain, I mean. You only look at an interval, okay? A small point, locally. And locally, you can find this point is the lowest point. So this is going to be the local minimum. Okay, now one more thing. This point is also the absolute minimum. You guys see why? Because if I don't just look at it locally, if I look at the entire function, you see what? This point is also the lowest point for the entire function, the entire graph. So this is local mean and absolute mean at the same time. Okay? We're at this point right here. This is a local mean. You see why? Because I can find an interval is the lowest point. But this is not the absolute mean, because in this graph right here, I can find some other point that even lower, okay, than the local mean. One more time, absolute mean means the lowest point on the entire graph. Local mean means what? The lowest point on the local region. Okay? And sometimes it may be the same, like this one right here. And how about this example? So you half a circle. I got half a circle. Okay? This graph has both maximum and minimum. This point right here is a maximum. What kind of maximum is it? Is it the local maximum? Yes, because I can find an open interval such that this is the highest point, so this is the local max. Is it the absolute maximum? Yes, it is an absolute maximum as well. Because for the entire function all the way from here to here, this is the entire function that I have. What? This is also the highest point. Okay? So this is the absolute maximum. It's the absolute max and local max at the same time. How about minimum? Do we have any minimum? Yes. Not just one. We have 2 points minimum. What kind of minimum are they? They are the absolute minimum. Because those 2 points are the lowest point for the graph. Okay? So it's the absolute minimum. So the next question is, are they the local minimum? This is a tricky question, huh? So this is way beyond our course. But if you study about topology and then we define open interval differently, then maybe. But for now, we don't define open interval that way. So I cannot find any open interval. We're talking our level. Okay? I cannot find any open interval around a point. So I cannot say that this is the local minimum, because by definition, you have a local minimum which you can find the local region. Okay? Open interval, got to be open interval, such that the point is the lowest. I cannot find an open interval because those are the endpoints. So what? Those are absolute minimum, but it's not the local minimum for now. Okay? Unless you define the open interval differently, but we don't do it yet in here. So just the absolute minimum, but not the local minimum. So after the section that we call right here, that's the topic we learn about maximum or minimum. Unless in the homework or in the quiz, in the exam, you guys are given a graph function, and then by looking at the graph, unless you'll be able to determine whether there is there's any maximum or minimum, and what kind of maximum or minimum they have, local or absolute. Okay. Now let me move on to the last item for section 3.3. I'll be talking about the secant line and the average rate of change. Let me use a black marker. I think it's easier for you guys to see. Item number 4. Secant line and the average rate of change. 2 things, so that shares us in the same topic. So let's start with the graph. Say I have a graph, okay? Any function, any graph. If I have 2 points on the graph, say the first point right here is say x1, y1. Second point right here is x2, y2. My 2 is too high. y2. Okay. So I have 2 points on the graph, and if I connect the 2 points on the graph, I'm going to have a straight line. And the name of that line is called the secant line. That's it. Secant line. Okay. So if people ask you, what is a secant line? Just the line that connects 2 points on the graph is called a secant line. Okay? Now that you have a line, you know how to find the slope of the line if you know 2 points. That's what we learned before. Slope of the secant line is what? M is equal to, we learned in chapter 2, right? The change of y over change of x is what? y2 minus y1 over x2 minus x1. Okay? That's the slope. And the slope of the secant line is called the average rate of change. So instead of writing M, people can call it the average rate of change. Average rate of change. Okay, there's no. Sometimes people will write R with the bar on top, average, or with R, AVE, or R average. Either way, this is equal to y2 minus y1 over x2 minus x1. So what is the average rate of change? The slope of this secant line. So what is the secant line? This is the line that goes through point on the graph. Okay? Alright, that is about the last topic. Let me give you a couple more examples and you guys can see the use of it. Okay? But this is all the idea. The secant line is a line that goes through 2 points on the graph. And then the average rate of change is no more than the slope of the secant line. Okay? The slope of the secant line is the average rate of change. Okay. So what is that all about? Why do they call it that way? Say you have a curve, just make an example. This is the revenue curve, okay? You open a business and you have a revenue curve. This is how much money you make, okay? At this point right here, is that cost? Is that revenue? Make sure it's right because I don't study economics that much, okay? And then this is how much you make for the first month, and then this is the second month time versus the money, okay? This is how much you make for the second month, and then what happened in here, you draw the line, go through point, you have the secant line, and you see what? The slope of the secant lines go down, the average rate of change go down. It means that you're kind of losing money, okay? It's that way. And then, say the second month to the third month, slope is going up, right? So it seems like you're making money, and then the third month to the fourth month, the slope is going up more. So in average, the third month to the fourth month, you make money, okay? So if you draw the line from here to here, it shows you what? Still a secant line, the blue line, okay? It's still going up. So the second one to the fourth month, you make more money, okay? You're making money, but compare the slope of this one to this line right here, is steeper. Means what? You make more, but it's less steep than this line right here. So you, in average, it's like average out between what? You earn a little for the second month, and you earn a lot for the third month. So this is average for 2 months, okay? And now look at the red line. You lost the money for the first, you earn some for the second, you earn more for the third. So what in average, the 3 months, 1, 2, 3, average is like the 3 slope. And then you have this red line right here, red secant line right here. It's still going up. That's why they call it average rate of change. Okay? Rate of change, rate of change, rate of change. Average rate of change for the whole interval. Hopefully that helps. Okay, now let's show you some math out of it. Just do some algebra. We call it lecture for the week. Okay, example. Example. If your f of x is equal to 2x cubed minus x plus 2. Let's just make up an example, okay? On the interval from, say, 0 to 1. You know what it means by this? It means this is your x1, and this means your x2. Okay? So, you can calculate f of x1, and this is x1, right? 0, you plug in 0 right here. You can calculate the y1 is f of x1. It's the same thing. Y1 is f of x1 or equal to f of 0 because x1 is equal to 0. You plug in 0, you got what? 2 times 0 cubed minus 0 plus 2. So this 0 is equal to 2. So you know that the first point is 0, comma 2, right? X is 0, y is 2. This is x1, this is y1. Similarly, you got x2 right here, 1. They always give you a function, an interval. Then you can calculate the first point and the last point, and then you can apply the formula to find the other rate of change. So y2, which is f of x2, which is f of 1, because x2 is 1, which is 2 times 1 cubed minus 1 plus 2. So let me calculate. This is 1, 2, 4 minus 1 equal to 3. Okay? So you know the second point on the graph will be x is 1, y is 3. Okay? So you're going to calculate the average rate of change. The average rate of change, I'm going to use this notation. It's the same thing for R bar. Okay? It's what? y2 minus y1 over x2 minus x1, which is 3 minus 2 over 1 minus 0 is equal to 1 over 1, which is 1. Okay? Or you can do what? y1 minus y2 over x1 minus x2 is going to be the same answer. It's going to be 2 minus 3 over 0 minus 1. You're going to have negative 1 over negative 1 is still equal to 1. Okay? And this is the average rate of change. Okay? So in general, you guys see the exercise in this topic right here, they're going to give you a function. And then on the interval, or they give you simply straightforward, give you what? x1, y1, and x2, y2. They ask you to find the average rate of change. Just calculate what? y2 minus y1 over x2 minus x1. Then you will have the answer. Okay? And this is the end of section 3.3. It's also the end of our video clip today. Thank you for watching, guys. As usual, please ask questions like many of you guys have asked previously in the last week. Any questions, just don't hesitate. Just ask me right away. And I am trying my best to answer your question as quick as I can so that you can get back to your work right away. Thank you for watching, everyone. Have a great week.